Dr. Rajiv sir, Samar sir, and my classmates and my juniors. I am Gadadhar Swain. Today my topic is CMOS sensor as ionizing radiation detector, which I have prepared under the guidance of Dr. Tanmay Das. These are my contents: motivation, detection technique, working principle of CMOS sensor, conversion of an ordinary webcam to a radiation detector, and limitation. Motivation. Why I am choosing this topic? All of you know radiation can be used as a various application, and millions of workers are occupationally exposed to the radiation, and workers are working in medical imaging, security, and environmental monitoring. They are exposed to high dose of radiation. So, inexpensive and easily accessible radiation level detector is in need for our purpose. So CMOS sensor is a device that can solve this problem to some extent. These are the techniques available for radiation detection. Like on the gas field detector, there are three detectors are available, like ionization chamber, proportional counter, Gim counter. Then another detector, that is scintillation detector, solid state detector, and some specialist detectors are also available, like to detect particles path, like gas chamber, bubble chamber, etc. This is the picture of a CMOS working display. Another thing I want to say, although there are a lot of detectors available to detect ionizing radiation, we specially emphasize the CMOS because it can be used as a consumer device, like either smartphone or webcam. Then working principle, as CMOS sensor can be operated based on the interaction of a ionizing particle with the semiconductor material like silicon or germanium. And CMOS sensor is consist of large number of pixel, and each pixel is consist of a photodiode, which is a semiconductor material, and this is working in the base of one, like in photodiode. This is the depletion region. This is P side, this is N side, and it pass in reverse bias condition. So in P terminal we connect negative side, and in N side we connect positive terminal of the battery. So in the working principle, in depletion layer, all of you know, in the reverse bias condition there is no flow of current in the external circuit. The resistance. When a ionization incident in the depletion layer, we know this is the valence band, this is the conduction band. When all of you know, in valence band, the valence band is completely filled with the electrons and holes, and conduction band is empty. When ionization incident on the depletion layer, then electron will jump, get sufficient energy to jump valence band to conduction band. Then a electron is available in conduction band, and a hole is created in valence band. So a electron and hole is created in this process. So now in conduction band there are we get a large number of electrons. So due to this large number of electrons, we get the current in the external circuit. This is the resistance. We get the current, and this current is due to the incoming radiation. Because when we reverse bias, there is no current. Then if you incoming radiation fall on the material photodiode, then we get the current in the external circuit. So we conclude that there is a presence of incoming radiation, and further we amplify this signal. This is the photodiode. In this picture, we want to say a small thing, that is comparison between CCD and CMOS. In case of CCD, each pixel, the pixel is the consist of a photodiode which we convert light to charge, and this charge is accumulated by each pixel, and this charge is the transfer for further process by horizontal shift resistor. If you see, this charge is transferred by horizontal shift resistor, so this charge is going to this place, and when this charge is further transferred by vertical shift resistor, and this charge is converted to voltage, and further by it is amplified. In case of CMOS, this light to charge conversion and amplification process is done in itself in pixels. So the processing speed of the CMOS is very fast than compared to CCD, and the power consumption is also less than CCD, and it can be comparatively less size than also CCD. Then the conversion of an ordinary webcam to radiation detector. How to convert an ordinary webcam to a radiation detector? So your front cover must be removed by using a screwdriver, and then dismantle the underlying base by removing the three small screws. So this is a normal webcam. By the screwdriver, we remove the front cover of this webcam. Then we remove this dismantle. Then this is the CMOS. Then we cover this CMOS by aluminum sheet to avoid the ambient amount of light. Then we check this original position. Then we connect this webcam to a software known as the thermal detector software. After some time, when we expose this webcam, we detect some spot on this software, and this length is the long length is the gives us the particles, which is the gamma particle. As we know, in gamma particle the penetration rate is very high compared to alpha and beta. So we get a large length, and the small dot is known as beta particle. This is my reference to collect this data. Limitation, it cannot use it for scientific purpose, because in case of CMOS we detect the ionizing radiation, but we cannot measure the energy of the incident radiation, and we cannot expose the sensor for last time. Because when we expose the sensor for last time, the pixel burn out.